Welcome to not Kahn Academy. Today we're going to prove the fact that the cube root of 2 is not rational. So it's irrational, it's not a ratio of two integers p and q. To prove this, we're going to use a proof by contradiction. As you might conclude, this is a proof that assumes something and then shows that this leads to a contradiction. In our case, we are going to assume that the cube root of 2 is rational, so it's a ratio between two integers, p and q, and those integers have to be co-prime. They can share a factor, is what that means. So if they were to share a factor like 3, then we could erase that from both sides of the division line. And we would have a ratio that is co-prime. So let's start with writing the equation down and cubing both sides to get rid of the cube root. Then we are going to get 2 is equal to p to the third divided by q to the third. Next, we're going to multiply by q to the third to get rid of the division, to get 2 times q to the third is equal to p to the third. Now we can see that p to the third is even, because it's 2 times something else, 2 times q to the third in this case. And that means that p must be even as well, because otherwise it would be odd, and then p to the third, an odd number to the third, would be odd as well. But that can't happen because p to the third is even. So we have just shown that p to the third and p are even. And now we're going to get back to our equation, and any number that is even can be written as 2 times some other number, like a, for example. That means we can insert that representation of p into our equation to get 2 times q to the third is equal to 2a all to the third. And now we can multiply that out to get 8 times a to the third. And we can divide both sides by 2 to get q cubed equals 4 times a cubed. This now implies that q to the third must be even as well, because it's 2 times something else, 2 times a to the third in this case, which also implies by the same logic as before that q has to be even. And now we have all the facts we need to show that this leads to a contradiction. P is even, q is even, and p and q are co-prime. But if p and q are both even, then that would mean they share the factor of 2, which can't be true because they are co-prime. This is the contradiction we were searching for, and now we can conclude that the cube root of 2 is not a ratio of two integers, p and q. And that just means that the cube root of 2 is irrational. Thanks for watching and hope to see you guys soon.